Right, I think we're there. Right. Right. Thanks, Thomas and Adam, thanks to the group for inviting me along to talk about my aerial photos website, wingvista.org. I'm Neil Miller. My main hobby is flying. Here's me with the aircraft that I own with 3 others, hanging at a farm airstrip near Andover in Hampshire at Coventry Airport 1 year ago. Part of the fun of flying, I think, is seeing the world from the air. So like most pilots, I take photos on my phone, and that started me thinking about ways to potentially automate this process, because I work in IT, that's kind of what I think about. Google has got its Street View service, which most people will be familiar with. Sorry. Well, basically, Google have taken a camera vehicle and driven it all around the roads around Britain and the world, and then you get these 360 photos like this, and you sort of go forwards and backwards. You understand the concept. So I thought to myself, thinking, I had the idea, why not lift the Street View concept up into the sky? So I bought one of these, a Samsung Gear 360 camera, and one of these, a Rocksteady mount, and one of these, a mobile phone, Android phone, and got coding. 6 years later, after spending far more time on the project than was sensible, and after collecting footage from most of my flights across the south of the UK, I had a version of a website that I was happy with. I called it Wing Vista, and you can Google it. So this is not my normal laptop. We had a problem with the video on it. So it's a top result owing to its slightly unusual name. So when you go into it, you can see you get a map of the south of the UK with a series of tracks overlaid on top of the map showing where I've flown. And if we zoom in a little bit, we can see that the we can see that they. Shall I use this method? Zoom in a bit. Finally, better late than never. You can see that it consists of. Yeah. Right. We can see that it consists of a series of circles, each one representing a photo that it's taken. Right, who here lives in outside London or in Zone 6? Anyone? No? No? Sorry. Okay, yeah. Sorry, Woking. Okay. Oh, well. Sorry. This is an Apple Mac, so I'm going to blame the computer because I'm used to Windows. Well, all right. Basically, you can probably guess. You click on one of the dots, and it shows the photo that was taken at that particular location. So this is a little bit south, sorry it's not working, but it's a little bit southwest of Reading there. And a little icon there shows the aircraft. So if we go back to here and turn it around a little bit, it's not the best photo. There's your Intrepid pilot. And I'm actually looking where I'm going for once, which is a slight rarity. And then if we scroll down here, we can then, with a bit of luck, zoom in and get some detail on the ground here. So I'm having a little bit of difficulty working out what's meant to be right click and left click on this thing. Yeah. Yeah, anyway, you get the idea. Oh, there we go, finally. So that zooms in. It looks a bit dark simply because it's towards the end of the day on this particular flight, so you can't see all that much. So it's basically, there's 8,000 images on the site, each one of which is 8 megs in size, so that's 63 gigs in total. And then if we click on this three-way toggle button, which might eventually work, we get an information screen which shows information about the flight, such as the date, time the photo was taken, the altitude I'm at in QNH, it's height above sea level, which means height in feet above sea level. And there we are. Oh. There we are. So this particular one, it's 1,400 feet above sea level. The latitude, longitude, this was taken on 21st of June 2020 during the time of COVID. That's one thing, we could actually go flying even though it's COVID because you're separated from people. Heading of 220, which is about southwest. And the calculated speed over the ground in knots. And then we've got this little thing up here which opens up the location of the photo in Google Maps. We should do. Finally, there we are. So you can compare what you can see on the camera with what Google's satellite view shows. So that's basically introduction to it. So how does it all work? It starts with a camera assembly here, which attaches to the aircraft using this mount here. And then with me in the cockpit is the second Android phone. So there's a little graphic I did here. There we are. Yes, my Microsoft Paint skills are amazing, aren't they? And then on the phone here, we've got an old version of a Google Street View application, which used to allow people to submit their own content to that particular service. So with the application, I've got it all running with a bit of luck. And so I should just be able to click here. And if you heard that, I don't know if you heard that little beep there, it started collecting the images. And it collects an image every 30 seconds. Here's one of the files that it has got. That was another one. Right. Yes. Oops. We'll get there eventually. Right. Finally, there we are. Right. So this is a sample image that it takes. And this slightly weird looking 360-degree raw format is called equirectangular. This was a flight I took in in the county of Gloucestershire. And it's a popular way to represent 360 data in 2D image files. That's GCHQ over there. And then rendering software converts this image on the fly into the 360 image that you can see. Then the GPS derived latitude and longitude data is in the file properties. I'll just get that. Oh. What am I doing wrong?
Press again.
Let's try that. No. Let's try that. No. If I just do a... Yeah. Ah, there we are. Well done, thank you. And then I think... Ah, there we are. No. Bring up properties on this, and nope. I think. Haha. Right. And in the details, so this is where the file gets saved onto the phone, and we'll scroll down here. The phone puts the latitude and longitude into the file metadata there. Yeah, and at the end of the flight, I copy the files from the phone onto my Windows server, which I'm actually on at the moment. This machine I'm on at the moment is in Hampshire, in my spare room, which I'm connected to with remote desktop connection. And then I run a command line utility called exif tool to extract the GPS information from the image files into the file names of newly created blank files in a new directory. And then I compile it by running a batch file. If I can bring that up. So it's a standard Windows batch, and I'll run over in just a moment once it runs through what it does. And while it's running, in summary, it loads the data into a Microsoft SQL Server database, processes it, then runs a Node.js compiler to compile the web application for the website, which is written in JavaScript, and then uses software called OpenLayers to produce the map and the tracks, and then Pannellum to display the 360 image in the browser. Right, so this is finished. Let's basically look at what it does. Let me know if that beeping's starting to annoy you. All right. Yeah, so the first thing it does is this. It runs this OSQL utility, which is a command line client for SQL Server. SQL Server is Microsoft's main relational database management system for on-premise machines and the underlying driver for SQL Azure in the cloud. The OSQL client runs what's called a stored procedure on the SQL Server, which we can see here is process wing vista is the name of the stored procedure. And we can see that the code for that stored procedure in this application here, which is called SQL Server Management Studio, which is the main GUI client application for SQL Server. And doesn't seem to be too keen on showing me what it looks. Oh, we are. Okay. Yeah. So this is code. Comprises of code written in SQL, which is called structured query language, which is a language used for data manipulation. The first thing this stored procedure, as it's called, does is it runs a Windows dir command on the file system to list the image files with their date times uploaded to the server and the corresponding longitude and latitude information written into the other files which I created, and loads it into a SQL table. Then it does a processing on it, which looks quite complicated, and in fact it is overcomplicated. Preparing for this talk, I went into the code and realised I'd overcomplicated it, and I could have actually done it in a more simple style. But there we are. Then it does the processing on the data to determine the metadata of a flight at each photo location, and it's the information in each photo. Including the GPS location, of course, but also the speed of the aircraft calculated from a ratio of the distance between the photos and the time difference. And heading, altitude, which comes from a separate tracking app, rate of climb, and image sequence number, which is an integer identifier for each individual photo. Once that's complete, the stored procedure outputs two files containing this metadata already mentioned, which I mentioned, and this here is one of the files output. Yeah, fine. Yeah, so this is an XML file. I'm not going to refresh it. Containing latitude, longitude, and time information, and then there's another file alongside that. This XML format is in a format called GPX, which I've got the Wikipedia link to here. There we are. GPX exchange format, XML schema. Going back to the batch, once it's output these files, scroll down a bit. Oh, we don't actually need to scroll down. The next bit of it is up here. Yeah, there we are. So it runs. Then the next bit is it compiles the code which is written in JavaScript, and this is where Node.js comes into it. It runs npm run build, which is Node.js's compiler. And then once that runs, it emits these output files which constitute the website code. And basically, the website code contains the compiled JavaScript code in conjunction with those two XML files, of which I've shown you one. I test it locally and then upload it to an Amazon S3 bucket, and then Amazon CloudFront hosts it as wingvista.org as HTTPS, the domain being managed by Amazon's Route 53 service. So there's quite a lot to it, actually, and it does work. Right, so how does the website display that map? The answer is it uses this technology called OpenLayers. This is a website for OpenLayers. As its name suggests, OpenLayers renders web pages by adding layers of detail on top of each other. The base layer, the tile or raster layer, is a map, which I had shown you here. And then on top of the map, you've got the tracks, which are the flight tracks. This is going to work. Come on. I'll come back in a minute. Right, yeah, so you've got the background map, and you've got the tracks, and then the third layer you've got this little red icon for the aircraft. The way I've implemented the map is by, it's basically I've got a directory containing individual, I've got a directory containing individual PNG files that stitched together make up the map background, and the OpenLayers software stitches that all together. And then the OpenLayers software puts this all on top. Let's have a look at the code itself, because I haven't actually shown you the code. So I've got the code here open in Visual Studio Code. There we are, it works. So it's about 1,000 lines of code or thereabouts. The main bit of it is on, no. How do I?
Press the green button.
Green, yeah. Thank you. Great. And we've got a. So we go to line 857 down here. With Control F. That's it. Escape. Right. 857. Right. Yeah, we are. Right. So yeah, the main bit of the code is this omap equals new mod map, where mod map is referenced at the beginning of it. So I'll go to Control G, go to line 1. It's up here, mod map, and that loads in from ol.map. Now that actually means ol/map.js. So it's a JavaScript file. Now that's the OpenLayers software installed on this web server where I compiled it. And it's only used during compilation. Once it's compiled, there's just a set of files that can be served up on IIS or Apache or any web server. And the client, when you're viewing a website in a browser, you don't need to install any special software at all. Right. So back to 857. We can see it. So it defines this OMAP object as being formed from the three layers: O layer background map, obviously background map, this vector layer, and the one for the aircraft icon. So looking at these in turn, 177. Yeah, the background map here, the way I've implemented it is just with a local reference to a local directory holding those PNG files. And then a bit further down, we've got 198. We've got the definition of this vector layer, and that, as you can see, references this GPX file that I showed you a bit earlier. And finally, we've got 169. 169. We've got this referencing the aircraft icon, which gets its data from this O-style aircraft icon, which comes from 421, which is here in this function call to set the aircraft icon. And the main thing that pulls it out of this PNG file, which which is the aircraft icon image, and then it applies a rotation. This is an OpenLayers function called rotation, which takes the heading, which is in sort of 90 is east, 180 south, multiplies it by 0.0174, which is a conversion into radians. Who remembers radians as a back to school, which is that's 2 pi over 360. Great. So that's that bit, and then so that displays the map, and then so what happens when we click on here? Obviously, if there we are. That looks a bit brighter, doesn't it? So when we click on it, it calls the function at 986. Where is it? There we are. So this is, I think it's called an event handler. It basically is a bit of code that runs in the web page and detects when you click, and it calls a function.click with a pixel. And that's defined on 436. Okay, yeah, and this goes through, I won't go through the details of this, but it detects whether it is a circle that's got a photo in it, on it. If it's not a circle, it just doesn't do anything. And then goes on to run a function render image. And how does that work? Well, that's defined on page 218. Here, function render image goes through some stuff. So it reads in a metadata that's behind the circle with all the metadata which you can see gets loaded into variables here from it's a JSON file that it reads, and so scroll down a bit. And then it constructs that. Construct a bit of HTML here. I know it's a bit redneck, a bit basic, but it works. Puts that into the website, and then finally it then calls at line 380 there we are, at the line at 380 finally, with knowing the values for the image, it calls this Pannellum viewer function, which displays the image itself. Pannellum is here. I've got the website for it. It's a nice bit of software, which displays right on its home page here, this image moves around, and it's easy to add the code in. So that's basically a description of, one other thing. And then there's other bits of code in here that detect if I'm sorry. We are. Oh, no. There we are. There's other bits of code. If I move this round, you'll see at the top these URL parameters change. So a moment image pitch is -19. If I drag it, there's code in that JS which will change that value. Right, so now change to -16 rather than 19. And then I can set this as well. If I left click here and get typing. So I'll change that to positive 60. It will, there we are, and it's looking upwards. So what that means is you can take a, just to prove that it does what it's supposed to. So that means you can take the complete URL and send it to people or save it. Good, right. Okay, so that's basically a description of the site, how it works. To round off, I've been to a number of different interesting locations. I think are interesting. During COVID, managed to, Gatwick Airport was closed and they opened it up to private pilots. So I was just able to fly over and get a fairly rare thing. And also, where else have I been? I've been down to the Scilly Isles on the southwest of the UK. I've been up to Blackpool. And then 3 years ago, one of the other pilots in the group, if I can get this working. Sorry. Come on. Maybe I should be building keyboard shortcuts to control this. That would work, wouldn't it? Maybe, yeah. It might be internet speed. We decided to go up and watch the British Grand Prix at Silverstone. So just click on here. See how it's going to work. Ah, there we are. So there we are. So obviously, the whole venue was quite full of people, and what have we got?
So if you keep circling over, you don't need a ticket.
Yeah, that's right. Yeah, we didn't have to pay at all. So this was where Hamilton and Verstappen had a crash. Hopefully that's going to work, and you can just about see it. I'm on. No. Yeah. We'll get there. Strange. Right. Control V. Yes, you can just about see the cars around here, and then if I press the up button, I mean Verstappen crashed, but he wasn't injured at all, which was quite amazing. You just about see, if I scroll in, sort of a cloud of dust. And the other guy in the excuse me, the other guy in the plane took a little video himself. And the sound doesn't work. Oh, well, there we are. Yeah, the internet is a bit slow. Oh, hang on. Okay, right. slightly amusing, I suppose. But as I said, no one got injured. And then Verstappen himself had a camera on board, which we can see here. And it sort of crashes. And of course, that's not the reason I showed you that. The reason is because I'll just stop. Ooh. Where is it? Sorry, be there in a minute. Yeah. Where was it hiding from me? I'll get there. No, it's not the best, but yeah, that's the sun, and yeah, I don't know. It's anyway. There's a little. I won't about what. There's a little white flash up there, and that's my aeroplane, and so that's so fame at last. So I shall finish there. I've probably overrun a bit. Where's that gone? Presentation. No, I don't wish to copy it.
Just tap enter.
Yeah, that's not carriage return. Ah, there we are. Good thinking. Right, so I'll leave it there. So my name is Neil Miller. This is a little wiki page I've set up on a Raspberry Pi in the last 24 hours with some links to that. So, yeah, does anyone have any questions? Yeah.
Do you have like other pilots that you work with to maybe like coordinate like a a network of multiple planes being able to map this?
Well, that's potentially a good idea. I mean, we've only got one aircraft, and as far as I'm aware, I'm the only pilot who's done anything like this. So most other pilots seem to be content just to fly around and take photos on the smartphones or sort of a camera also. Yeah.
What were the red lines? So like you can see the kind of small icons and everything that you had. There seem to be
Yeah.
red lines that
Yes.
zoomed all the way back to origin.
Yeah, that's kind of a bug really. Although I've got lots of separate flights, it is actually a way that it's done in the code is a single line. So it just happens to be going from the end of one flight onto the beginning of another flight. Yeah. Any more?
Thank you, Phil.
Yeah.